Okay, welcome to the second part of the Unit 4.3 review. Let's go ahead and get started. The first part of this review is on another video where I worked through the quiz problems that I had signed. So this is going to cover all the other problems that were not covered on the first part of the review. In problem 2, they're asking us to write in a single logarithm and reduce all fractions. So because we are subtracting two logarithms with the same base, we are going to divide. So this becomes log base 4 of 16 divided by 256. Okay, and 16 divided by 256 reduces down to 1 over 16. And that is a single logarithm, so that is all you need to do. Now on number 4, instead of subtracting two logarithms with the same base, we're adding two logarithms. We are adding log base 8 of 4 plus log base 8 of 16. So we are going to rewrite this as log base 8 of 4 times 16. And that becomes log base 8 of 64. Okay, so now here we're adding on number 5, subtracting two logarithms with the same base. So this becomes log base 5 of 375 divided by 3. Or in other words, log base 5 of 125. Okay? And that is the first section. Okay, let's move on to the second. On problem 8, we have an exponent of 2. And our logarithm properties allow us to bring that exponent out front. So this is 2 times log base 7 of 49. Now, the way we figure out what log base 7 of 49 is we think, what power can I raise 7 to give me 49? And 7 squared is 49. So if we raise 7 to the second power, it would give us 49. And so log base 7 of 49 is 2. 2 times 2 equals 4. Okay, on problem 9, we have two bases that already match. So this 17 is the base of this exponential expression. And in the exponent, the logarithm has a base of 17. So the way I handle those is if the bases match, I scratch. And what I'm left with is 0.73. Okay, so that is my answer to problem 9. Alright, on problem, and those were the only two problems we didn't do in the other video, so let's move on to the next section. The evaluate section, they're just asking us to plug into our calculator. So on 15, I'm going to plug in log base 6 of 300 into my calculator. So I hit control, and then the 10 raised to the x button is the log button. So log base 6 of 300 is 3.18334, so I have to round. So I look at the number right past my thousandths place, which is the fourth number after the decimal point, which is 3. And because it is less than 5, I do not need to round my thousandths place value up. I just keep it as it is. So my final answer from number 15 is 3.183. 3.183. Okay, number 18 is the next problem we didn't do in that section on our quiz, which is log base 4 of 13. Go to my calculator, I hit control 10 raised to the x for my log. Base 4 of 13. I hit enter, and my value is 1.85022. So my final answer to number 18 is 1.850. On problem 20, they're asking us to evaluate ln of 0. Now, the natural log has its own special button on the calculator. So I hit control E raised to the x because that is the natural log button. The ln, you notice the ln above it. So it's ln of 0. I hit enter, and you notice that it gives me an undefined. That means that 0 for an x value is not defined on the natural log function. 0 is not in the domain of the natural log function. So my answer to number 20 is undefined. Okay, moving on to the next section where we're solving exponential and logarithmic equations. On problem on your review sheet it says 13. We've changed the numbers on the document for next year already. So now this is problem 21, which is the equivalent to the second problem 13 on your sheet. And here we have the same, we have 2 raised to the 2x minus 1 equals 8 raised to the x plus 1. And if you have 2 exponentials on each side, you have to make the bases match. So we have to rewrite this 8 somehow with a base of 2. And we know that 8 is 2 raised to the third. So that's what we're going to do first, is rewrite 8 as 2 raised to the third power. Now here we have a power raised to a power, so we have to multiply 3 times x minus 1. So you end up with 2 raised to the 2x minus 1 equals 2 times 3x plus 3. Remember, you have to distribute that 3. So now that we have our bases matching, we can go ahead and drop them. So we're left with 2x equals 1. 2x minus 1 equals 3x plus 3. I apologize. And the way we solve is we get all of our x's on one side and all of our variables on the other. So I'm going to go ahead and subtract 2x over. And you end up with negative 1 equals x plus 3. And I'm going to subtract 3 from both sides. And I end up with x equals negative 4. Okay? Moving on to problem 22, or 14 on your sheet. We have an exponential on one side, and we're solving for x. And the way I do this is if there's only an exponential on one side, I can log roll it to become a log function. So we're going to rewrite this as a log function because it's the opposite of an exponential. So I always start with my base, pick up the 20, and then go back and pick up the x minus 1. So I'm going to write this as log base 3 of 20 equals x minus 1. Now all I need to do is go into my calculator and type in log base 3 of 20. And I find out that it is 2.72683. I apologize. Is equal to x minus 1. So then all I have to do is add 1 to both sides, and x equals 3.727. If we're rounding to the nearest thousandth, I have to make sure my third decimal place is rounded appropriately. So that is my final answer to problem 22, is 3.727. Okay, on problem 23 or 15 on your sheet, we have a log on one side. So if we have a logarithm on one side, we're going to go ahead and do the log roll to convert it to an exponential. So I start with my base of 7, pick up the 3, and then the 3 back to the 5x plus 3. So we write it as 7, my base is 7, raised to the third power equals 5x plus 3. Now, 7 to the third power, I go to my calculator, type that in, is 343. So 343 equals 5x plus 3. So I subtract 3 from both sides, and I end up with 340 equals 5x. Then I divide by 5 on both sides, and x equals 68 is going to be my final answer to number 23. All right, let's move on to problem 18 on y'all's sheet, which is actually 26 on this worksheet right here. So if you notice, we have to simplify both sides of the equation before we can move on. So I'm going to simplify this log base 3 of 4x plus log base 3 of 6. And since we are adding logarithms with the same base, we're going to go ahead and multiply 4x and 6. So we write it as log base 3 of 4x times 6 equals 5. And 4x times 6 becomes 24x. Now, since we have a logarithm on one side and we're solving for x, we're going to log roll it and convert it to an exponential. Always start with your base, pick up the other side, and then go back to the 24x. So we're going to write this as 3 raised to the 5th power equals 24x. Now, 3 raised to the 5th power, we type in our calculator, is 243. So 243 equals 24x. Then we just need to divide both sides by 24. And x equals 81 over 8, or x equals 10.125. Either answer is acceptable. Okay, moving on to problem 20 on y'all's worksheet and 28 on mine. Here we have two exponentials with a base of e, and since they match, we can go ahead and drop them. So 2x minus 2 equals x plus 3 is what we're left with. And now we want to go ahead and get all of our x's on one side and all of our constants on the other. So I'm going to subtract x first, and I end up with x minus 2 equals 3. Then I add 2 to both sides, and I end up with x equals 5. Okay, problem 21 on y'all's sheet and 29 on this problem. We're subtracting the natural log of 15x minus the natural log of 3 equals the natural log of 45. So, remember, natural log has the same properties as logarithms. So here, since we're subtracting two natural logs, we're going to go ahead and divide the larger numbers. So this becomes ln of 15x divided by 3 equals ln of 45. So it's ln of 5x equals ln of 45. And now that we have a single natural log on both sides, we can drop it, and we're left with 5x equals 45. Divide by 5 on both sides, and x equals 9. All right, you doing all right? Hang in there. Now we're moving on to the word problems. I did the first 2 word problems on the other video for this review, so go ahead and look back at those if you need to. And we are now going to do the last 2. The second to last problem says that Claire bought her first sports car 3 years ago for $21,500, and she read in a magazine that her car's value will decrease, that's the key word right there, by 5.3% each year. So the formula that I'm going to use is A of t equals P times 1 minus R raised to the t. And the reason I chose that is because there's no mention of compounding, so we don't need to use either of our compounding formulas. And in this case, we have a decreasing value, so we're going to put that subtraction sign between the 1 and the R. And the way I write this is A of t equals 21,000. P is the initial value of $21,500. So I plug that in for P. And then the rate, R, it's decreasing by 5.3%. And when we convert that percentage to decimal, it's to 0.053. So it's 1 minus 0.053 raised to the t. And when you simplify that, it comes out to be A of t equals 21,500 times 0.947 raised to the t. Okay, so either one of those is acceptable as the final answer. Now, it's in part B, they're asking, after how many years and months will her car be worth half of what she bought it for? So, well, she bought it for $21,500. Half the price is going to be $10,750. So, the amount of the car should eventually equal $10,750. And that's equal to the original equation that we came up with in problem 1. So we're going to set that equal to 21,500 times 0.947 raised to the t. Okay, so now we need to solve for t, the number of years it takes to reach that 10,750 amount. So first thing we have to do is divide by 21,500. And we're left with 1/2 equals 0.947 raised to the t. So we have an exponential, and the way we need to do this is convert it to a logarithmic equation to solve for t. So we start with our base of 0.947, pick up the 1/2, and then go back to the t. So I'm going to write this as log base 0.947 of 1/2 equals t. And now all I do to find what that t value is go type that into my calculator. So I'm going to type in log base 0.947 to the 0.5. 0.5 is equal to 1/2. I hit enter. And my t value is 12.7285. But remember, they want this in years and months. So this is 12.7285 years, but we need to put it in terms of years and months. So we know it's 12 years. And the way we figure out the additional months is we take this decimal portion right here and multiply it by 12. So I'm going to go into my calculator and multiply 0.7285 by 12. And you notice that it's about 8.742 months. So I'm going to round that up to 9. So in order, it's going to be 12 years and 9 months for Claire's car to reach half the amount. Okay, let's move on to the last problem. On problem 33, they tell us $1,000 is invested to an account that pays 5% interest compounded continuously. So what we need to recognize here is the words compounded continuously. That tells us what kind of formula we're going to use up at the top. And this compounded formula is different than the last compounded formula we used on the last test. When you see the words compounded continuously used together, you have to use the formula A of t equals P times E raised to the R times t. Okay, so make sure you know the difference between this compounding formula and this compounding formula. This one is used for the compounded continuously. So, like I said, we're going to use A of t equals P times E raised to the R t. And our initial value that was invested, P, is $1,000. And the rate at which it's increasing is 5%, or 0.05. In part A, asks us to write an equation that represents the value of the investment after t years. So, all I do is plug in P and R. So, A of t equals 1,000 for P, E raised to the 0.05 for the rate, times t. Okay, and that's my answer. That's all I have to do is plug in for P and R. On part B, they ask us how much will the investment be worth in 8 years. So that means T is equal to 8, and that's all I'm going to do is plug that in. So A of 8 equals 1,000 times E raised to the 0.05 times 8, which is equal to $1,491.82. All right, when you plug that in your calculator. On part C, They want to know in how many years and months will the investment be worth $6,000. So that means the equation we came up with, or the equation we came up with in part A is going to be equal to $6,000. So 6,000 is equal to 1,000 times e raised to the 0.05 times t. And we are looking, our goal is to solve for t. Okay, that's what we're wanting to find, the number of years that it takes to reach $6,000. So I'm going to divide by 1,000 first to get rid of that. And you end up with 6 equals e raised to the 0.05 times t. Now, since we have an exponential equation, we want to write it as a logarithmic equation. So we always start with our base. Remember, we're going to log roll. Start with our base, pick up the 6, and then go back to the exponent of 0.05 times t. So I'm going to write this as log base e of 6 equals 0.05 times t. So when I go to my calculator and type in log base e of 6, control log base e of 6. And remember, e is not a variable, e is a number. So it's just that letter e, there's a calculator that distinguishes that e. So log base e of 6, hit enter. Oh, I didn't like that. Let's go ahead and tell you what. Let's rewrite log base e, we know is ln. Log base e is the natural log. So let's go ahead and rewrite log base e as ln. So ln of 6 equals 0.05 times t. And let's see if the calculator likes that a little bit better than this. So I'm going to hit control e raised to the x, which is the ln button. ln of 6. And let's see what we get. We get 1.79176. So I'm going to go ahead and write ln of 6 as 1.79176 equals 0.05 times t. Then I divide both sides by 0.05. So I go into my calculator and divide by 0.05. And you end up with t value of 35.8352 years. So t equals 35.8352 years. But remember, they want to know how many years and months. So we need to convert this decimal value into years and months. So we know it's 35 years in so many months, but how do we find those so many months? We take this decimal value of 0.8352 and multiply it by 12 in our calculator. So I'm going to take 0.8352 and multiply it by 12, and the number of months is 10. So we get about 10 months. Our answer is 35 years and 10 months for the investment to be worth $6,000. Okay, I hope this video was helpful. Good luck studying for your test, and come in and see us if you have any questions. Good luck tomorrow.